Well, you thought you were free of me because my kid is sick, but turns out that you have to listen to me anyways. So there were some folks that told me today that they had trouble understanding the video last time of the 30, 60, 90 triangle here. And so I'm going to go over it again, and just to make sure that everybody understands how to do this stuff. Alright, so what we're talking about is a 30, 60, 90 triangle. The 30, 60, 90 triangle, if you would imagine just a regular equilateral triangle, okay, this is a triangle that's equal on all sides, right? So if this side is 2, then this side is 2, and then this side is 2. So if that's the case, what are the angles of your equilateral triangle? Alright, Jackie, you answer this one. Go ahead. 60 is correct. Alright, so 60 degrees, the angles of each of the equilateral triangles. That one looks like a 66. It's really just 60. Okay, so you've got an equilateral triangle with three 60-degree angles right here. Okay, so what does that have to do with a 30, 60, 90 triangle? Well, I want you to imagine a line that comes right down the middle there, okay? And it makes a complete right angle, boom, with this right here. And so we've got a nice right angle, boom, boom. And you know, of course, that right angle is 90 degrees. And you know that this angle right here is still 60 degrees. But this angle now isn't 60 degrees anymore. It's been cut in half, right? And so what is the new angle? 30 degrees. All right, so just to be clear, we have a new triangle. That's this guy right here, this new triangle. And it's a 30, 60, 90 triangle. And it's got, still has a hypotenuse of 2, right? This is our C. So if we have C squared equals A squared plus B squared, this is our C right here. That's our hypotenuse, right? Okay? So here's the other thing about this is that look at the bottom of this triangle right there. This is the bottom. It was an equilateral triangle, but it got cut in half, didn't it? Now, since it was an equilateral triangle, the total side was 2, right? When it was a full equilateral triangle. But this is half of 2. You might see where I'm going with this. What is half of 2, folks? 1, right? Okay. So we've got this. I'm going to erase the rest of this because we don't need any more of our equilateral triangle anymore, because we've proven that if our 30, 60, 90 triangle has a hypotenuse of 2, then its short leg is 1. Now we just need to figure out what this is, right? Okay, so we can do that by our c squared plus a, or c squared equals a squared plus b squared, our Pythagorean theorem. Now we know that our c squared is 2, so I'm just going to say 2 squared equals, and let's just say that this guy, number 1, is a and x is b over here. Well, a squared is 1 squared equals b, or I mean plus b squared. And so let's square all these guys out. 2 squared is 4 equals 1 squared is still 1 plus b squared. We subtract 1 from both sides and we get 3 equals b squared. And then so we want to take the square root of both sides to get rid of this ugly square right here. And so we get b equals the square root of 3. Okay, so where's our b? right here, right? So instead of just b, we're going to get rid of that b, and now we can replace it with the square root of 3. And so now we have a 30, 60, 90 triangle. This is our 30, 60, 90 triangle right here. The small side is 1. The larger leg is root 3. And the hypotenuse is 2. Okay, well, we've got that right here. So let me push this aside, and then we're going to take a look at that just by itself. So to give it a nice, well, that's not quite 30, 60, 90, but that's okay. All right, let's just say that this is 30 degrees. Let's say that this is our 60 degrees, and let's say that this is our 90 degrees. Okay. All right. Now, at first we said that this was 1, 2, square root 3. All right? Remember, we just took that from the last triangle. Okay. So, remember what I asked you guys to do with the 45, 45, 90 triangle. Whenever you had a triangle that you had one side of, and you needed to find the other two sides, and it was a 45, 45, 90 triangle, we're going to do the same thing here. And if you don't remember, then that's okay. I'll remind you. Let's take a look. Let's shrink this. Let's push it up a little bit here, and let me give you a triangle. Okay, let's say that I wanted you to find something that had this side was 4, and it was a 30, 60, 90 triangle, all right? And so I said, okay, you have that. I want you to find this side, the side opposite my 30. Okay, so I'm looking at this side right here. I know this side on my 30, 60, 90 triangle. This side is 4. I'm trying to find x. Alright, so here's what I do. So I'm going to set up my ratio. Now, I always draw the triangle first. I draw my known triangle. Remember, I'm going to draw this triangle right here. And this is my known triangle, and I'm always going to label it. I've got 1, 2, and the square root of 3. It's important that you remember what those sides are, okay? I always start with my x. Here's my x right here, and I'll say, oop, x over, well, since this side of my known triangle corresponds with this side of the triangle that I'm trying to figure out, then I'm going to take the value of this side and I'm just going to move it over. Whoop! I'm having trouble with this here. Oh my goodness. I'm going to move it over here. Okay? Make sense so far? Then, here, let me erase some of this stuff here. Boop, 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 boop. Boop, boop, boop. Wow. Okay, so I've set up my first ratio. And then, or my first fraction. And then, I'm going to take the side that I know, which is 4 over here. That's the side that they gave me. And I'm going to put it over the corresponding side of my known triangle. Alright? So, I'm going to take this 4 right there. And then put it over the square root of 3. Alright? Now I've set up my triangle. Now notice what I did. I started with my x, and I put it over the corresponding side of my known triangle. And so this is what I got for that. Okay? And then I took what I had as my known, or what I knew on the triangle that I was working on, that 4 right here, and then I put it over the corresponding side of my known triangle. And that's 4 right here. Now another thing I want you guys to notice is that where do the numbers that are on the tops of the fractions come from? These numbers, this x and 4 that are on the tops of the fractions, do they come from my known triangle, or do they come from the triangle that I'm trying to figure out x for? Well, of course they come from the triangle that I'm trying to figure out x for. Look on the bottom here, my 1 and my root 3. Where do those numbers come from? They come from my known triangle. Alright? So, we set this up. Now we have x, basically x equals 4 over the square root of 3. Can I leave this as my answer? No is the answer for that one. Why? Because I've got this right here. I've got my radical. I need to get rid of that radical. If I could just erase it, it would be so much easier. But alas, I can't. So now I've got to go back over here. Why don't we do green? Okay. I've got to go back over here. I've got to write 4 over the square root of 3. And remember, I've got to get rid of this radical right here. So 4 over the square root of 3 times the square root of 3 over the square root of 3. Now, why am I doing it times the square root of 3 over the square root of 3? Because I need to get rid of the radical. I need to get rid of the radical. Joseph, pay attention. Joseph, what did I just say? I need to get rid of the radical. Okay. So, the square root of 3 times the square root of 3 is equal to 3, right? Alright, so we said the square root of 3 times the square root of 3 is equal to 3. Notice that there is no square root sign on this. When I multiplied the square root of 3 times the square root of 3, I was able to get rid of that square root sign, right? But when I multiply 4 times the square root of 3, I am not able to get rid of that square root sign, so that is just 4 root 3. Okay, so now, can I reduce this at all? Can I do anything with this? Jackie, what do you think? Am I done? Jackie, you're right as always, of course. I am done. Yes, the answer is 4 times the square root of 3 over 3. Alright, so let's try one more here. I'm going to get rid of this and move all of this stuff over. Away you go. Okay, so don't forget, I'm looking at my 30, 60, 90 triangle. Yes? Yes? Yes. Okay. And what was opposite the 30-degree angle? Remember, that's the smallest leg. That was number 1. What was opposite my 60-degree angle, my longest leg? That was the square root of 3. And what is opposite my 90-degree angle? A 2. Now guys, if you can't remember this, just look at this. 1, 2, 3. All you have to remember is that you put the square root on the side of 3. If you can't, just remember 1, 2, 3 for your 30, 60, 90. And remember, your smallest leg is 1, so it should be opposite your smallest angle. Your biggest leg here is 2. Your biggest hypotenuse is 2, so that should be opposite your 90 degrees. And so the square root of 3 is right in the middle. Okay. So, I want you to solve this one. Okay. Go ahead and write this on a sheet of paper. All right. I'm going to give you that leg right there. That's our longest leg. Go ahead and pause this video and see if you can figure that one out. And oh, here. If we didn't already, let's say we're looking for this side. Okay, go ahead and pause it if you didn't already. Alright. So, you should have started with your x and put it over the corresponding side of your known triangle, x over 1, okay? And then you should have gotten the part of the triangle that you were working on that you know, which is that 7, and then put it over the and then put it over the corresponding side of the triangle that you're working on. And you would have gotten your answer. Now, remember that, well, we're not done yet, but remember that you are cross multiplying. Usually, but if you come up with x over 1, then you don't really have to cross multiply. Why? Because x over 1 is the same as x equals. Remember, x over 1 is the same as x. So you just have x equals 7 over the square root of 3. And you don't really have to cross multiply. So, but you do have to get that radical out of the denominator. So you get x equals 7 times the square root of 3 over 3. Ta-da! All right. Well, I want you guys to turn to page 358, and I want you guys to take a look at example 3 because it talks about just what we were talking about, and then go over to page 360, and I want you guys to try numbers 1 through 15 on page 360. I will be taking these up. These will be for a grade. So make sure you know how to do it. Make sure you have worked through each of these problems. I want you guys to be doing this individually and I want you guys to be working on this quietly. The substitute that you have is an amazing person because he or she was able to sub in for me at last second's notice, and I am grateful to this person. So please treat them with respect and make them feel like a guest in our classroom. And you know how big I am on respect. I expect that you guys show that to the sub by working. Especially you, Joseph. All right. See you tomorrow.